Well, welcome everybody. Welcome back to the CIB Purdue Joint Conference Series that we are broadcasting from Purdue University. I'm Mark Hustak, and this would be a recorded session that we continue advancing women researchers in the built environment. And in that series, if you're attending our seminars for the past weeks, we have already showcased several distinguished speakers, and we continue that trend today by bringing forward two researchers. And let me introduce both of them briefly. And the first is Dr. Sogand Hasanzadeh. She's director of I2 Safe, which is Intelligent Inclusive Safe Lab, and she's an assistant professor in the Lyle School of Civil Engineering and Construction Engineering and Management at Purdue University. She received her PhD from Virginia Tech in civil engineering. Her research focuses on advancing smart safety and building smart communities through the application of digital twins, advanced sensing, XR, VR, AR, MR, and artificial intelligence. Her interdisciplinary work is looking for creating a shared language between civil engineering, data science, computer science, human factors, and cognitive behavioral psychology that leads to more informed engineering solutions in response to the current and future challenges in complex construction projects. Her research studies are supported by the National Science Foundation, several Department of Transportations, construction companies, and Electra International. Her work also has repeatedly been recognized nationally and internationally, and she has been a very successful researcher in her career thus far. Our second speaker is Shiva Pooladvand. I hope I pronounced that correctly.
Yeah.
She's a PhD candidate in civil engineering at Purdue University. She also received her MSc in construction engineering and management from University of Tehran in Iran. Her research focuses on incorporating immersive technologies, namely VR, AR, MR, wearable sensing, and human factors concepts to advance safety and productivity. She works on several funded projects by the National Science Foundation, Electra International, and Indiana Department of Transportation, which has resulted in several journal publications and conference presentations. Her exceptional work received the Oral Excellence Award from the Society of Functional Near-Infrared Spectroscopy in 2022, Research Finalist Award from IEEE, Industrial Applications Society, the IEEE Industrial Applications Society in 2022, Industrial Choice Award from the Construction Industry Institute, CII, in 2022, and a journal paper was awarded as the editorial choice paper by the ASC Journal of Construction Engineering and Management. She's an upcoming early career researcher. And with that brief introduction to both of them, let me hand it over to Sogand and Shiva, please.
Thank you. Thank you so much, Professor Hustak, for a great introduction and very nice one. So, hi, everyone. Thank you so much for joining the session. We are so excited to share part of our research that's being done in our lab that Shiva is gonna taking care of. So let's do a little bit introduction about me. So Professor Hustak already mentioned that I'm assistant professor here at Lyle School of Civil Engineering and Construction Engineering and Management at Purdue University. So I should shout out to all my team members so far. And then those that they listed on the left-hand side are the ones that they are current member. The right-hand side are the ones that they already graduated, and some of them might be now in this call. Plus the undergraduate research assistant. So all the works that will be presented in this presentation, we should shout out also to them and all their contribution for the data collection and data analysis. So what we are doing in I2 Safe Lab, we are exploring several aspects of the technology and applied sciences in order to suggest engineering solution and behavioral intervention in response to the challenges that we are facing in the current workplaces and the future workplaces. So one of the most important part of our research team is that taking into what is actually is the problem and how we can translate our research findings into the practical application to be used in the construction industry or other industry that they need to deal with the human factor concepts or the workers. So one of the main important focus of our team is to make sure that the next we will prepare the next generation of professionals and the leaders by equipping them with this knowledge about these different technological advances that is happening in our industry and how it's going to change the industry, how they can be the game changer in the future. So the research that we are doing in our team is very, very interdisciplinary. So we are having like civil engineering concept, construction engineering and management concept, but we are combining that one with the psychology, neuroscience, computer science, biomedical engineering, mechanical engineering, because then nowadays in the new world, we cannot solve the problem if we only say like we are not going to do the civil engineering research. So interdisciplinary research, bringing different disciplines together and adopting different approach, different concept, different technology from different disciplines will definitely help in order to address the problem in a better way. And you're going to see some example of that one that when I said like it's in the interdisciplinary, when Shiva start talking about it. So you see three key terms that we talk about it. Like that is our lab stands for the intelligent and inclusive safe built environment. So developing intelligent infrastructure and technological advances, make sure that the construction job site or other workplaces will be inclusive place. And most importantly, we want to ensure that we will reach the highest project performance, especially safety. So in this presentation, we're mainly going to focus on the construction safety and a little bit about productivity. So no doubt that all of us know about it, that construction industry is one of the most hazardous industry worldwide. And when we look at the statistics, you're going to see that among other industries, one of the toppest in terms of number of injuries and fatalities. So there are every year we're going to see there are hundreds of injuries and fatalities that they are happening in construction industry. Through years, there are many efforts in order to develop safety training, safety standards, compelling use of the personal protective equipment in order to reduce this number of injuries and fatalities and bring it to zero. But so far, we're not like successful to reach to zero. It was reduced, but still it's happening. And one of the reasons that is happening is that when we look at any incidents that are happening in the workplace, it has two sides. When the unsafe behavior coincides with the unsafe site conditions, then we're going to have incidents. So many efforts are putting to just have safety technological advances or other technology to make sure that the construction job site or other places will be safe. But what will happen to that unsafe behavior? There are many, many factors that can impact or lead to the unsafe behavior of workers. One of those ones are stressors. So stressors are nowadays capturing a lot of attention. When we are talking about the stressors, we are talking about internal stressors and external stressors. Internal stressors like being impatient, being perfectionist, that all of us are like suffering to some degree from each one of those ones, which means that the source of the stress are internal, inside the person. But there are other aspects that is external stressors. External stressors are related more about occupational stressors, the task that they are doing, the organization that they are working to, the environment that they are working on. That Shiva is going to more expand on that one later on. But when we talk about these types of stressors, the concern is not only going to be safety. We will have concern about safety, health, and well-being of the individual. So mental health concern is already like surging worldwide. And construction industry is one of those industries that is actually the construction workers are more vulnerable to these challenges. We're going to see the high suicide rate. We're going to see the high rates for the mental health issues or concerns in construction industry. And one of the main contributor factor into these ones as stressors. And most of them is coming from the external stressor or the work that they are doing, the task that they are doing, the pressure that they are under when they are working in the construction industry. So I'm now going to pass it to Shiva. Shiva is going to provide an overview about part of her doctoral dissertation that is focusing on external stressors. Shiva, floor is yours.
Thank you, Dr. Sogand. So hi, everybody. Welcome to today's seminar session. I'm very glad that I have the opportunity today to present part of my research. Okay, let's start. So as Dr. Sogand mentioned, there are different kind of internal stressors that can threaten workers' safety within the construction industry because of the hazardous nature of this industry. But we also have some external stressors that they can threaten workers' safety within the construction job sites. Based on the literature, I have selected the most important external stressors to investigate the effect of them on workers' risk-taking behavior within the construction industry. The first category is task stressors that I'm going to talk about time pressure and mental demand under that. Then I have social stressors that under that I'm going to talk about peer influence or peer pressure. And the last category are environmental stressors that I have heat stress under that I'm going to talk about it. But now we want to see why it is important to see the effect of these stressors on workers' risk-taking behavior. So it is important because these stressors can increase human error. So now let's see what is human error. So human error refers to individuals' errors and mistakes. For example, if they have inaccurate judgment, and it can happen due to lack of situational awareness. And based on the literature, human error has been identified for the reason of 80% of construction incidents. So this is a huge number that can capture the attention for further investigation. Now, we want to see how may stress cause human error. To answer to this question, I want to go over the situational awareness model developed by Ensley, that you can see here. So this is a very well-established model that it has been used in many different kinds of studies that they are investigating human error or human factor. So based on this model, individuals will process the information in their surrounding environment based on 3 levels. And after these 3 levels, they will make a decision and then take an action. Okay, let's go over each one of these levels one by one. So in the first level, individuals will understand that what is happening in their surrounding environment. This level is a perception level. Then we have the second level, which is level 2, that is the comprehension level, in which individuals try to understand that why they need to care, that something is happening around them. And then we have the third level, which is the projection level, that individuals try to understand what they need to do. Okay, something is happening, and now what they need to do about that. So after these 3 levels, they will make a decision and take an action. But the point here is that stress can disturb each levels of situational awareness. And finally, it can impair individuals' decision-making process and can cause unsafe behaviors, which can increase the rate of incidents within the construction job sites. Now I want to go over each external stressors that I mentioned in the 2 slides ago to provide you with more details about them. At first, I want to start with the environmental stressor or heat stress. As you may know, heat stress means being exposed to extreme heat in a way that the body cannot get rid of that. So this is a very serious concern within the construction industry because most of the construction tasks need to be performed outdoor. So workers need to be exposed to direct sunlight, specifically during the summer. Despite a very well investigation in other domains, for example, such as mining and military, about the adverse effect of heat stress on individuals, there are not that much sufficient study within the construction sector. So based on the literature, high ambient temperature can impact worker safety performance by increasing their physical fatigue and also mental fatigue. So high ambient temperature can distract individuals. And also it can cause very different kind of heat-related illness, for example, such as heat stroke. Now the question here is how heat stress can affect individuals or workers, situational awareness and safety performance. Now, I want to talk about social stressor, that I have peer pressure under that. So peer pressure means a feeling that one must do the same thing as others are doing in the same group, to be liked by them, be respected by them, or, for example, to increase their gains. This is also a very serious concern within the construction industry, because most of the construction tasks need to perform in a group of people. So workers need to work together to achieve a common goal. And there are different kinds of studies, for example, in driving area, that if you search, you can see that, for example, studies about drivers' risk-taking behavior when they are alone or when they are driving with passengers. So this is a very serious concern, but again, no attention has been paid to this concern within the construction industry. And based on in the literature, we know that the presence of risky peers can influence individuals' risk-taking behavior. And workers' risk-taking behavior in the construction job sites is expected to be impact each other's risk-taking orientations. So here the question is that how peer pressure can influence workers' risk-taking behavior and decision-making within the hazardous situation in the construction industry. And the last category that I'm going to talk about now is the task stressors, that under that I have time pressure and mental demand. Okay, let's see what is time pressure. Time pressure means being pushed to work faster. And mental demand can happen when workers need to work on different tasks simultaneously. So these two stressors are also very serious and common within the construction job sites, because of the dynamic nature of this industry. For example, these two can happen when the project is behind the schedule. So in this situation, workers need to work faster to catch up with the stuff, or maybe they need to work on simultaneous tasks together. So such increases in productivity can put workers under stress and impair their safety performance. Now, the question here is that how these two stressors can impact workers' risk compensatory behavior, and also how these two stressors can impact workers' situational awareness. Because here I mentioned risk compensatory behavior, I want to provide you a general overview about this behavior. So risk compensation is a theory that has been proposed by Wild in 1986. So based on this theory, people try to adjust their risk-taking behavior to achieve a balance between potential risk and benefits that they can have out of a hazardous situation. In the context of my study that I'm working on construction safety, this theory means that workers will take more risk if they are protected because of a false sense of security. So these are the two questions that I'm going to answer throughout my presentation. At first, we're gonna see that whether task stressors such as time pressure and cognitive demand can worsen the negative effects of risk compensation. And the second question is that whether task stressors can increase workers' stress level and impair their situational awareness. To answer to these two questions, I have selected a high-risk task within the electrical construction sector, which is the line replacement task. So this is a very common task within the sector, that line workers need to work on high energized power lines in order to replace an old pole with a new pole. So they need to remove energized power lines from the old pole to the new pole without disconnecting the electricity. So you can imagine that this is a very stressful and high-risk situation. So in order to answer to those two questions, I have asked human subjects, 33 human subjects, to perform this task while I was measuring their real-time objective measures such as brain activation, heart rate, and also subjective measures through the questionnaires. But since it is not logical to ask human subjects to perform that high-risk task in real world, because I want to do my research, I don't want to kill people. And also, I really need to capture the nationalistic behavior of individuals within those hazardous situations to answer to those two questions. So I have developed a mixed reality environment, as you can see in this slide. This environment consisted of two models, the virtual model and the physical model. So the visual model includes a 3D representation of a US suburban area, as you can see in this slide. And the physical model includes passive haptic, such as bucket, insulating gloves, hot stick, and fall protection, as you can see here. So passive haptic means the actual things that they are going to be used in the virtual environment. And then after synchronizing these two models, I mean the virtual model and the physical model, I had the mixed reality environment. And by adding different kind of environmental modalities, such as, for example, sound of the car that they were passing, or wind, I tried to increase subjects' sense of presence, means that they were actually in that environment. After creating the mixed reality environment, then I immersed the human subjects in that environment using the VR headset. And then I used motion trackers to synchronize the movements of the actual person with the virtual avatar that was in the environment, as you can see in this slide. Another cool thing about this environment is that if subjects were very close to the pool, to the virtual pool actually, so they could experience incidents that was the arc flash, or which is an electrical discharge. So they could see the visual representation of that, and also they could hear the sound of that. And after seeing that, they were visually dead, actually. Okay, so this is the framework that I use to immerse the human subjects into that in order to ask them to do the line replacement task. But in this environment, I asked them to perform this task under 3 different conditions. In the first condition, which is the normal condition, I asked them to perform the task without any stressors, so everything was fine, and they were just performing the task based on their own pace. And then in the second condition, I asked them to perform the task under time pressure because I wanted to expose them to time pressure. For that, I have subtracted about 10 seconds of the duration that it took for each individual to perform the task in the first condition. And then I asked them to perform the task again. And in the last condition, or condition 3, I asked them to perform the task under both time pressure and mental demand. So the time pressure is the same as the condition 2. And for the mental demand, I asked them to perform a secondary task, which was a 2-back working memory task. So 2-back working memory task is a well-established psychological-based task that it has been widely used to manipulate working memory resources. So working memory resources are capacity limited and are the important resources for decision making. So in the third condition, subjects were performing the main task, which was the line replacement task, under the time pressure, while they were also supposed to respond to the 2-back working memory task, in which they were hearing a random sequence of numbers, and they were supposed to say yes if the number was similar with the number in the 2 trials ago. So you can see that the demand under mental resources was a lot in the third condition because they were engaged with 2 tasks. And there are also 2 other important points about this experiment, that in all 3 conditions, subjects were provided with full protection. So they were completely protected. They had fall protection, insulating gloves, and everything that they needed. And in the second and third condition, they were told that they will receive extra compensation if they can finish the task within the time. Here you can see the general overview of the mixed reality environment that I explained. So as you can see, all the movements of the actual subjects are synchronized with the movements of the virtual subject. And you can see that he is replacing the bubble lines on the pools. So when subjects were performing this task, I measured their real-time physiological and neurophysiological using the different kind of wearable sensing technologies. For example, I use fNIRS to measure their brain activation. I use empirical wristband, which is a medical wristband, to measure their stress level and risk perception. I measured their attentional distribution using the eye trackers that they were embedded in the headset, and I used the motion sensors to synchronize their movements and also measure their track their positions. Okay. Now, so far I was explaining everything related to the experimental design and the data collection process that I immerse the human subjects in the environment to collect their data. Now I want to talk about the findings out of this study. At first, I want to see the effect of time pressure and mental demand on risk compensatory behavior. So to investigate that, I used a subject's brain cortical activation. So as I said, I measure subject's brain activation with FNIRS. There are different kind of methods to measure a human's brain activation, for example, and the most widely used ones are FNIRS and EEG. But since EEG is very sensitive to motion artifacts, and you could see that in my experiment, subjects needed to move a lot. So I couldn't use EEG, and FNIRS is more robust to motion artifacts. So I decided to go with FNIRS. So FNIRS work based on near-infrared light. And the light goes from the transmitter to the receiver to measure the changes in the oxygenated hemoglobin within the blood, which is a measure of brain activation. Here in this slide, you can see that this is the optode or sensor arrangement of the FNIRS that I use for my study. And based on the purpose of my study, I decided to divide the brain into different areas. You can see I have 5 areas here. Area A and B are covering the prefrontal cortex, which is very, very important in cognitive processes, such as, for example, risk perception, working memory, and decision making. And then I have area C, D, and E, which are covering the motor cortex, which is an important area for motor planning, controlling, and executing of movements. Here, in these plots, you can see the distribution of the oxygenated hemoglobin, which is a measure of brain activation across the areas that I explained over the experimental conditions. I mean condition 1, 2, and 3. So the light blue is showing the normal condition in which subjects perform the task without any stressor. The medium blue is showing the second condition in which they were under time pressure, and the dark blue is showing the third condition in which subjects were performing the task when they were under both time pressure and a mental demand because of the two-back working memory task. So as you can see, generally, there is an increasing rate in the brain activation from the normal condition to the most stressful condition, which was the last condition. But I want to take a closer look at these graphs. For example, consider area A and B, which were covering the prefrontal cortex. We can see higher brain activation within the second condition compared to the first condition, which was the normal condition, because of the task difficulty that subjects were exposed to. Task difficulty, I mean that subjects were using the actual hockey stick where they were performing the task. So they were equipped with all the protections that they needed in the real environment, and they were performing the task within a limited amount of time, which could increase the demand on their mental resources for processing the information in their surrounding environment and making a decision. So this is the reason that we could see higher brain activation within the second condition compared to the first condition. And you can see that in the last condition, which was the most stressful condition, we can see higher brain activation, which is significantly different with the normal condition. The reason of that is subjects were performing the main task under time pressure, while they were also exposed to a secondary task, the two-back working memory task, which could kind of increase lots of demands on their mental resources. So this is the reason that we can see higher brain activation in the last condition compared to the normal condition. And now I want to look at area E, C, and D, which are covering the prefrontal cortex. So the increases in the brain activation in this area is because subjects were using the actual hockey stick, actual things that they need to use in the real world with the same weight and same length. So they could actually perceive that weight when they were moving the hockey stick. The hockey stick is the thing that they were using that to replace the power lines from the old pool to the new pool. So this is the reason that we can see the higher activation also within their motor cortex, which is showing the engagement of the resources in this brain area. Here you can see a graphical representation of the brain area of the subjects over the experimental conditions. So based on the spectrum, the blue color is showing the lower brain activation, and the red color is showing higher brain activation. So as you see, when we are going from the normal condition to the most stressful condition, we can see more red colors. So this is showing the increases in the demand on mental resources, specifically within the prefrontal cortex, which is a very important area in decision making. So these results are showing us the dominant function of the prefrontal cortex in the risk decision making process. Now I want to talk about subjects' overall performance, that how they perform the task generally. So I measure their overall performance in each condition based on the nature of the condition. For example, in condition 1, the overall performance was measured based on not experiencing arc flash. In the second condition, it was based on not experiencing arc flash and also completing the task within the time. And in the third condition, it was measured based on not experiencing arc flash, completing the task on time, and also providing accurate responses for the 2-back working memory task that I asked them. So based on the graph that you can see in this slide, there was a significant reduction in their overall performance within the stressful conditions. You can see that they were experiencing about 30% reduction in overall performance in condition 2 and about 42% decrease in condition 3. So all these results are showing us that time pressure and cognitive demand or mental demand can worsen the effect of risk compensation. So I explained that what is risk compensation. Under the stressful conditions, subjects were perceiving, okay, they are protected, nothing will happen to them, and they just need to be worried about completing the task on time. So they just speed up to finish the task on time, and they ended up experiencing more incidents or arc flash in my experiment. Now I want to see the effect of time pressure and mental demand on worker situational awareness, which is the second question that I was mentioning earlier. So to investigate this, I have measured subjects' visual search pattern or attentional distribution over the scene based on their fixation duration. Fixation duration means the time that subjects were fixated on a specific area. And for the specific areas, I have selected 2 areas or areas of interest: hazardous areas of interest and non-hazardous areas of interest. Okay, what is hazardous areas of interest? Hazardous areas of interest were the areas that they were source of the hazard. For example, the power cables in the environment, or for example, the poles. And non-hazardous areas of interest or AOIs were those that they were not the source of the hazard. I mean, everything in the environment except the hazardous one. For example, trees that they were in the environment. Also, I measured subjects' stress level based on the data I captured with the empirical wristband, based on their EDR, which is their electrodermal activity, which measured the changes in skin conductivity, and also their heart rate. Or HR. So I measured the stress level based on these 2 measures when they were generally performing the task over the 3 conditions that I explained, and also when they were looking at the source of hazards, hazardous areas of interest and non-hazardous areas of interest. Okay, so in this slide, you can see subject stress level measured by both EDR or electrodermal activity and their HR. So these 2 measures are well-established measures in order to measure stress level based on the literature. So generally, we can see higher arousal and stress level within the stressful conditions compared to the normal condition, which is significantly different. So we can see that under the stressful conditions, because of the time pressure and mental demand, subjects were experiencing a higher level of stress. Here you can see subjects' attentional distribution measured by the percentage of fixation duration. So I selected the percentage of fixation duration because each subject finished the task within a specific amount of time. And since I wanted to compare them together, I normalized the data and I decided to go with the percentage of fixation duration. So this graph is showing the percentage of the fixation duration, which is a measure for attentional distribution over the experimental conditions. The gray color is showing the attentional distribution over the non-hazardous areas, and the orange color is showing the attentional distribution over the hazardous areas. So if you look at the graph, you can see that from the normal condition to the most stressful condition, as the stress was increasing, subjects' attentional distribution on non-hazardous areas are increasing, while their attentional distribution over the hazardous areas is decreasing. So here we can see a cognitive failure, which is known as attentional tunneling. So attentional tunneling means the allocation of attention to particular information for a duration, for a longer duration, while ignoring the other important information in the environment, which is the case within the stressful conditions, I mean condition 2 and 3 in my experiment. So when subjects were under stress, that stress caused reduced alertness, and it impaired their perception of potential risk in the environment. So they couldn't properly allocate their attention to the important or hazardous elements in the environment, and which could increase their risk-taking behaviors. In this slide, you can see subjects' stress level that was measured by EDR and HR. So again, the gray color is showing their stress level over the non-hazardous areas, and the orange color is showing their stress level over the hazardous areas during the 3 experimental conditions that I explained. So generally, we can see higher stress level, as I mentioned, from the normal condition to the most stressful condition when they were looking at both source of the hazards, I mean hazardous and non-hazardous. But taking a closer look on the normal condition. So the middle line in the graph on the bin plot is showing the average. So we can see that subjects' stress level was kind of fairly higher when they were looking at the hazardous areas of interest, which means that when they were in a normal condition without any stressor, they were actually stressed because of the risk in the environment, and they were perceiving the actual risk of the task. However, if we look at their stress level within the stressful conditions, we can see that the middle line, which is showing the average stress level over both hazardous and non-hazardous AUIs, are kind of close together, which means that under the stressful condition, they were not stressed because of the risk in the environment, and they were stressed because of something else. And what was that something else? I validated these based on the subjective data when I asked them that why you were stressed under the stressful conditions. And most of them, they said that they were stressed because of losing the compensation, because they were told that they will receive extra compensation if they finish the task on time. So you can see that under a stressful condition, they couldn't make a rational decision. Actually, that stress changed their rational decision-making process. And instead of focusing on the potential risk in the environment, they were just focusing on receiving that extra compensation. So they just decided to speed up to finish the task on time. And they didn't care about the risk in the task. Here, these results are very interesting. So these are showing the correlation between the attentional distribution measured by fixation duration and the stress level measured by both heart rate and EDR over the experimental conditions. Again, the orange color is related to the data related to the hazardous AUIs, and the gray color are showing the data related to the non-hazardous AUIs. So here again, I want to take a closer look at the normal condition. So in the normal condition, in which subjects were not under stress and they will just performing the task based on their own pace, you can see that the stress level was lower. And the important thing here is that you can see that the dots related to the hazardous areas and non-hazardous areas are separated from each other, which means that subjects were assigning their attention mostly to the hazardous areas. You can see that the orange dots are higher compared to the gray dots. So they were selectively assigning their attention to the hazardous areas of the environment, and they were focused on those. However, we can see in the stressful condition, the dots are getting closer together, which means that they couldn't focus on the important elements in the environment, and they were just shifting their attention between different elements that were in the environment. So this is showing us another cognitive failure, which is the impaired selective attention. So selective attention is a very important cognitive ability which enables individuals to focus on the task that they are doing while ignoring the irrelevant information. But you can see that under the stressful condition, subjects didn't have a appropriate selective attention because that stress actually disturbed them, and they couldn't focus, and they just ended up sharing their mental resources or attentional resources between different elements in the environment, which could increase their risk-taking behavior. Okay, now I want to correlate all the results that I explained so far with the situational awareness model that I explained at the beginning, and I mentioned it has been proposed by Ensley. So this is that situational awareness model. Based on my result, we saw that stress can impair subjects' hazard identification. We could see that under stress, they couldn't focus their attention on the hazardous or important elements in the environment. So this is related to the first level of the situational awareness model. And then we also saw that under stress, they didn't have accurate risk perception. They were stressed because of losing the compensation, not because of the risk in the task, which is related to level 2 of the model. And then failures in level 1 and 2 caused also failures in level 3, in which they didn't have an accurate judgment. And failures in all 3 levels caused failures in decision making. So they had irrational decision making, and finally they ended up just speeding up, and which could lead to unsafe behavior. So these results are also correlated with the performance error that I measured during each condition. As you can see, subjects had higher performance error in the last condition, which was the most stressful condition. Okay, now based on all the results that I explained, we can conclude that more protection can produce a false sense of security, and which can increase workers' risk-taking behavior because of the risk compensation effect. And also, we could see that time pressure and mental demand can increase workers' stress level. It can cause different kind of cognitive failures, such as, for example, impaired selective attention and cognitive tunneling that I explained. And we could see that these two stressors can increase workers' risk-taking behavior. And based on the results that I explained, I mean, it is expected that these results can increase the awareness of safety professionals to understand how safety protection may increase workers' risk-taking behavior. Also, these results can increase safety professionals and also workers' awareness about the conditions under which workers may take additional risk, or they may get distracted. And all this information can help us to lay the foundation for improving the current worker safety training and designing evidence-based safety interventions in order to mitigate the adverse effect of such task stressors. So out of this research, I have published 2 journal papers and 2 conference papers. So if you are interested to understand more details about this research, you can read the papers as well. And now you may be wondering that what happened to the other 2 categories of external stressors that I was mentioning at the beginning. So this is an ongoing research that now I'm working on. So to investigate the effect of those 2 external stressors, I mean heat stress and peer pressure, I have developed the state-of-the-art extended reality environment, as you can see in this slide. So extended reality is a kind of very cool and new environment compared to the mixed reality and virtual reality, because it has the pass-through headset, so individuals can see both virtual environment and actual environment next to each other. So it's a very unique experience. But unfortunately, since I don't have the time today to explain the results that I got in this part of my research, I will be happy if I can have the opportunity in the future to just go over all the details about this experiment, because I have simulated both heat stress and peer pressure in this environment, and the results are very interesting. And thank you so much for your attention.
Great, thank you so much, Shiva. So as you see, we just based on the limited time that we have, Shiva went through how the task stressors that actually one of the main source of stressors in the construction industry, and how it can impact workers, and not only like how subjectively ask them how it's impacting them, to see that how it will impact their behavior by looking at their physiological and also neuropsychophysiological responses of them. So I think with that one, if you're interested and you have questions about the heat stress or the peer effect ones, I think she will be happy to answer those questions. But shout out to all our team members, and that they help with all the research that's going on, and even like supporting Shiva when she was just like collecting data. Thank to some of you that you may also serve as the participants. But so we will be happy to answer any questions that you have.
Thank you, Sogand. Thank you, Shiva. That was a very interesting presentation, and I'm sure there are a number of questions that people are wanting to ask. So please, I cannot see everybody, but open your mic and please go ahead and ask your questions. Yes, Dave.
Yeah, I'm curious if there's any sense of like the findings here. Would you envision that the application would be just to train people that they might be more risky, or would there ever be an instance where some of the safety equipment would be deemed too much? And I maybe draw the analogy to American football. Folks say maybe wearing the helmet makes the game more dangerous because people are going to collide more because they think they're safer. But I couldn't envision playing football without a helmet. I mean, we play touch football, but we're not as rough. Do you think that there would ever be some devices that wouldn't be or would be considered too much?
Sorry, I think I missed the first part of your question. If you can repeat that again, I would appreciate that. Sorry.
Just with the sense that the safety equipment is leading people to take on more risk, what do you envision might be the application of this to industry? Would it just be the fact that you would train people that, oh, you're wearing this equipment, you may be more risky, don't be more risky? Or do you envision that there would be some equipment that would be deemed too much, or this equipment is just making folks risky, therefore we're having folks use less safety equipment, which seems kind of absurd, but if they're being more risky, then I think there's some evidence that just training folks and just hearing, oh, this is risky, may not be really useful.
Okay. Thank you so much for this great question. So actually, the thing that you were mentioning about the football, that was very interesting. It was very similar to the things that we were discussing in the context of construction industry. So based on the risk compensation theory that I explained, this is something that is very common, that people will take additional risk when they think that they are protected and they have the false sense of security that, okay, nothing will happen to them. But the thing is that, the application of this within the construction industry can be increasing the awareness of the workers, that it doesn't mean if you are fully protected, it doesn't mean that you can take additional risks. For example, if you have fall protection, it doesn't mean that you can get very close to the edge because you may fall. So we should kind of train them. We should increase their awareness about that false sense of security that they may face. So this is something that we can do by training the workers. And also we can, for example, think of maybe some kind of approaches that we can, those kind of evidence-based and intervention that I was mentioning during my presentation, some kind of approaches that we can use to, for example, more help, further help workers to, for example, behave safe. For example, if they are protected, I don't know, if they are working close to edge and they have the fall protection, there should be, for example, some signs there that, okay, you are protected, but here is a hazardous area that you should pay attention.
adding to what Shiva mentioned, Dave, so there are many ways that it can be like applied in the construction industry as well as for a football player. There are some studies actually about football players, and then the hard hat or the helmet that they wear, and then how wearing that one will give them a false sense of security, as Shiva mentioned. So always in these types of behavioral and cognitive biases, the first thing is that the awareness is very important, as Shiva mentioned. So raising awareness of our industry, raising awareness of the football player, the degree that the intervention or technological advances or safety protection is actually going to protect them is very important. So they usually will overestimate or over-rely on those types of technology. They're not getting knowledge, obtaining enough knowledge, and raise their awareness about this phenomenon, that to what extent it can protect them. It can be the first intervention. There is nothing in the training, the current safety training, as Shiva mentioned, that is actually touch anything about risk compensation. It's only like that, okay, if you use this polar rest system, you will be fine. So that should be added to the official training that the workers will receive or the football players will receive, to not overestimate that one. But they can be also some technology to warn them when they start taking more risk. So, for example, part of the additional things that Shiva is doing is that we are working on the advanced sensing that actually will come to help when the person are not going to take that the risk compensation seriously, or they start taking more risk. So because we need to have different layers of protection. One of them is going to be training, awareness, and the second one is going to be intervention or advanced sensing that will come to rescue when they are not paying attention to. But that's a great area of research, and the future steps that hopefully Shiva, when she graduates, she will follow up on those ones.
Thank you, Dave. Thank you for that question. Anybody else? If you have a question, please open your mic and ask.
Hi, this is Larry Longman. I have a question, or maybe an observation.
Go ahead, please.
Yeah,
yes,
no
go
problem.
ahead.
So it's been almost 30 years since I've been in a Purdue classroom. So looking at this, maybe from the real world perspective, maybe just a couple comments. The subjects were students, that didn't necessarily have the specific knowledge of that task or the industry. One thing that I see on this end is that there's some additional stressors for workers, such as an aging workforce. We're dealing with a lot of guys that are starting to age out of craft, and they are not being replaced by younger workers. Younger workers are encouraged more so to go to college than they are blue collar trades, if you will. So I think that might add to the stressors that would impact what has been studied here. Along with the aging workforce, a lot of times we see injuries, hurt, stamina, long-term impacts that lessen an employee's ability to do the same tasks that they might have been doing for 30 or 40 years over and over again. And then lastly, as workers become good in their craft, they generally travel across the country to do that specific trade because of how good they are with it. But while they are doing that, they're away from their families, traveling. Sometimes two things, I guess, if affects their mental position, and that they aren't really surrounded by their usual things while they're on the road. And then two, they might be hurrying and hasty on, say, Mondays or Fridays when they are trying to take long weekends to travel back. So I just wanted to add that, if that's something that adds any value to the perspectives that were brought here today.
Thank you.
Awesome.
Thank you so much. Yeah. So that was a very great point that actually we were discussing at the beginning. Me and also Dr. Sogand mentioned that there are different kind of stressors that they can affect workers' risk-taking behavior. For example, the age that you mentioned, the migration is I myself have read lots of papers about the workers that they need to go to somewhere else to work. So those are the things that they can affect. Also, but it's kind of out of the scope of my research. But those are very interesting, and we hope that in the future we will have enough time also to cover those kind of stressors.
Yeah,
Great, thank you.
there are very good points. Some part of like the aging workforce, we are covering that one, and Sean's research, my other PhD student, that we are looking at how the aging will impact the safety performance of the workers. And so here like designing the experiments and running the experiments, we should make sure that we do not have like compounding effect. So as you said, there are many factors that can impact workers, but like in Shiva's research is mainly like once upon a time we just focusing on each one of them, because we should know like how each one of them will impact, and then we'll look at the comprehensive, because each worker might deal with several of these ones, especially internal like stressors, or some of the things that is about like being far from the family, aging, and other factors that you mentioned. So that's why like that there were like 9 different types of experiment that Shiva did. Like 3 of them, it's about the task stressors and mental stressors. 3 of them, it's about the heat stress, and 3 of them are about the peer effect. So 9 different types of experiment, and in each one of them 30 to 40 participants in each. In this one, we use the students purposefully, because then, as you said, experience will impact, we will have another impact here. So we need to make sure that everyone receive the same training and will do the task in the same way. So that's why we need to control, when we are running the experiment, we need to control the impact of the other factors. But in the next steps, it's actually being used, and then the intervention, the suggestions, is actually being incorporated with the actual workers. But great comments and great points that is happening in our industry, and we need to take care of it.
Thank you, Larry. I think that was really important points that you raised, particularly about the aging workforce and of course the stresses due to travel that might be in news because of staying away from families and others. So thanks for that question. Anybody else? Please again.
Yes, Professor. I have
yes, you
a
can.
question.
Yes, go ahead, please.
Hi, Shiva, really great presentation, first of all. And I know you're someone who did the experiment with both virtual reality and mixed reality. So this is something that was like personally close to me. And what a question I have is, what risk perception difference you particularly felt like on a higher level between experiments that was like clearly virtual reality, for example, electric, they could really see that it's all graphical, compared to something like roofing that was partially, reality. So what was the key difference that you found in the risk perception of any participants that you had?
Mm-hmm. Thank you so much, Sogand, for your great question. So as I was also explaining during my presentation, extended reality is a very unique and kind of novel experience compared to mixed reality and virtual reality. So in extended reality, individuals have the opportunity to see both actual and virtual environment. So in the roofing experiment that I was showing briefly the videos, when subjects were on the roof, they could see the roof, they could see their hands, their body, but the rest of the environment was a projection of the virtual environment, and they could imagine themselves on the top of a 2-story building, while a virtual worker was working next to them. So based on the results that I got out of that study, subjects had more sense of presence in that mixed reality, extended reality environment compared to the mixed reality environment. And the sense of presence means the sense that subjects have that they are actually in the environment. Because our research is investigating behavior and cognitive responses of individuals, it is very important to capture the naturalistic ones. So that extended reality environment can provide kind of better opportunity to capture that naturalistic behavior in terms of the risk perception that you mentioned. So I can say that extended reality compared to other kind of immersive environments, it is a very more helpful environment to capture the actual risk perception of subjects while doing this kind of experiments. If Dr. Sogand has any comments that she wants to add.
Sogand. Any more
Thank you.
questions?
I have a
The-
question, if it's possible.
Yes, go ahead. Who is this?
Uh,
Yes,
Hi,
Ali, go ahead,
Shiva.
please.
Hi.
Hi, Shiva. Thanks for your presentation. I have a quick question. Can the VR experience that we have be changing based on the performance of the workers? Because we have a variety of workers with a variety of performances and with variety of abilities. And is this experience be changing during the experience he have?
So I didn't get your question. I think it's
So
about
it was
I
the
mean-
assessment, Mohammed. It's because it's like the set of the experiment that they need to do that one. So the experiment is not changing based on the people performance, because the experiment should
Okay.
be fixed in order to keep the validity and reliability. But if you're asking about like customizing or personalizing for each person based on how the person is making mistake or doing good or bad, or just see that how they will have follow-up behavior, I can say what Sean and Yugenher did. Yugenher is a part of his master, and Sean part of the PhD that he's doing. They are focusing on that one, that like they change the mixed reality environment based on the performance of the participant. But if I understood your question correctly, so this is for Shiva, it should be set experiment, so we will keep the like validity of the responses, because we want to see that under a specific condition how the participant will react or will make a decision.
Yeah, okay, that's correct. Now, my question is that how we consider these changing performances. For example, we have a worker at the first, he's not a performance and he doesn't have a good performance, but time has changed and he has a good performance at the end of the experience, and maybe some days passed. Thank you very much.
The learning curve is something that is very important. As Shiva mentioned, Shiva counterbalance the conditions in order to make sure that the learning curve is not going to impact their behavior, because each one of them did the experiment several times, but the order that they go through is different. So because all the people will learn by doing, and then that can be about the roofing or electrical one. But it's like the important part is that to ensure that what we assess is the impact of task stressors, not impact of learning. That's why that Shiva planned to do that, like the counterbalance that one. But doing by working, having more experience will bring more complacency, will bring more effective, like more effects to the experiment. That will be also very interesting to consider.
That's great. Thank you for your response.
Thank you, Mohammed. Appreciate that question. Ali, did you have a question you were going to ask?
Yes.
ahead,
Good job,
please.
Shiva. Great presentation, nice animations. So I basically had two questions. The first question is about, did you see the impact of external conditions like heat, stress, and then time pressure on the productivity of the workers, or basically the duration of each of those phases of the cognitive model that you have? So that's the one, then I can go ahead and ask the second one.
That's a great question. Thank you for asking that. So actually, the question that you are asking about the productivity is among those results that I didn't have time to present, that is related to the heat stress, that it's about the roofing experiment that I was showing the kind of experimental design about that. So I haven't investigated that, for example, how different levels of heat can affect workers' productivity. For example, I asked them to complete a task that is, it has a kind of defined borders. For example, they need to install, I'm now explaining everything that I didn't explain during my presentation, because in the roofing, they need to install asphalt shingles on the roof, okay? Actual asphalt shingles on the roof. So they need, for example, to install 24 shingles in each condition. I manipulated the temperature within the three conditions. I have no heat, low heat, and high heat. And then I have investigated that how those different levels of heat can affect workers' productivity. For example, based on the number of shingles they are installing, the time that they are taking to install the shingles, and different kind of stuff. But I will present the results in the future to you because we are close together. So if you are interested.
Yeah, sure, of course.
Yeah.
That's great. So the second question is about the memory task, two-back memory task, if I remember the name correctly. So it's kind of, I would say, obvious or trivial that if you increase the heat stress or memory load on the worker, they're going to increase, their error is going to be increased, right? So that is kind of, so the extent of increase is something that I think can be more valuable. So having that said, in a real world working situation, what is the real world representation or equivalent to that memory, two-back memory task? So does this happen? How much memory load are the workers facing in real world construction? Did I ask the question? And then, yeah, how much is the impact?
Yeah, I got your question. Thank you so much again for this insightful question. Actually, that was a very great question that I was also facing this question several times. So the actual example, I mean, in real world about this working memory task is, I was explaining the experiment that was about electrical workers that they need to replace power lines from an old pool to a new pool. Yes, so this is a very high risk situation. So the actual example of, so that working memory task is for what? It's for increasing the load on their mental resources, yes? So the actual situation that can happen in real world is, for example, they are working on that task when there's a thunderstorm and they don't need to, I mean, they cannot, for example, disconnect the electricity. So they need to be very fast. They need to communicate with each other very fast. So they need to maybe perform different kind of tasks together to be able to just finish the task and have the electricity ready for the, I don't know, city, the town, everything. So this is the actual thing that can happen in real world. If I have explained good for you. So did you get your answer?
Yeah, sounds good. Sounds
Good.
good. Thank you.
Actually, there
Thank you,
are
Ali.
several tasks, Ali, to just do it at the same time. So construction workers, as Shiva mentioned, the coordination with each other, taking care of their safety as they are on roof, and then installing shingles. Like the other stress that they are coming from the task or from the organization. So so it's just like now, if someone just focusing on the task that they are doing, they definitely going to be at risk in the dynamic construction environment. So, but there are different ways when you put them at the job site, their mental load is being occupied. And you should consider that none of us, when we go to the work, we are like, our mind is free of other things. So when we are, even like when we are driving, you are thinking about the other aspects. So there are many things that will occupy part of the working memory. So they might have some money issues. They might just be distracted with their cell phone. They might have like argued with their spouse in the morning. So who knows what is going on in each person's life. So part of the working memory is occupied with that one. And as Shiva mentioned, so cognitive resources are very limited for human. If part of that one is occupied, the other half or other part of or remaining part of that one needs to take care of other tasks. And consider the dynamic environment of the construction job site, this is gonna be a big deal. Why two-back task is that? Because in order to simulate something that is about psychology, it's about cognitive resources, some well-established methods should be used. And two-back task is the well-established method in psychology to simulate the condition that they will face, because occupying part of their working memory and then see that how they will perform the task.
Great, thank you.
Great,
Thank
thanks.
you, Ali. Any other questions? Please open your mic.
Yes, I have a question if you have time.
Yes, go ahead, Bajit.
Yeah, so I have a couple of questions. First, I would like to thank you for giving this great presentation. So my two questions are regarding the effect of heat stress and the productivity of the volunteers. So the first question is, based on my understanding on your research, you did the monitoring of heat stress on like closed environment, right?
Yes.
So how do you use any index to track the heat stress? I mean, what type of index did you use?
Okay. Again, thank you at first. Thank you so much for your question. Again, your question is related to the part that I didn't present.
Yeah,
I know. So this is, if I want to talk about that, I can talk for half an hour. So it's a very long story. But shortly, I can tell you that because for my experimental design, I have simulated the heat stress. So I have defined that I want to have no heat, low heat, and high heat. Okay. For no heat, it's the room temperature that the heat index is, and based on some kind of well-established kind of tables for temperature and humidity, we can find the heat index. For example, if the temperature is like this, or if and also the humidity is like this, for example, the fields of the environment will be like this. Okay. So based on that, I have found, okay, so for example, if I want to reach to 107 Fahrenheit as the high heat condition that I use, I need to have the temperature, for example, as 95 Fahrenheit, and the humidity should be 50%. So
okay, got it.
I used a climate chamber that is a specific room to simulate the heat stress. So in that room, I was able to set the temperature and humidity to reach to what I want. Did I answer to your question?
Yes, you did. So my second question is regarding the productivity. How do you measure the productivity of the volunteers?
Okay. So this is something that I'm now working on, but there are different kind of definitions for measuring the productivity. So it can be measured based on the number of shingles that they have installed, for example, over a specific duration, considering the conditions that they were doing the task under that. For example, it was low heat, it was high heat, or it was no heat.
Oh, so you are using cycle tracking.
Sorry?
You are using the cycle tracking. How many do they perform during like 1 hour?
Yes, and then, for example, because they have, different kinds of subjects, they perform this task under different conditions, and then we can have within subjects analysis and also between subjects analysis to investigate, for example, how their productivity has changed based on, maybe we can also consider some kind of individual characteristics. For example, people who were more sensitive to heat stress or people who were not that much sensitive to heat stress. And then we can investigate that how their productivity has changed.
Great, thank you. As for myself, I'm studying the effect of heat stress levels of productivity on Saudi Arabia. I would like to know more about your research. Maybe like some other time we could meet and talk about it. Well, thank you for answering my question.
Sure. Feel free to reach out. I think like there can be a very interesting discussion about this one, because I know that in Saudi Arabia it's going to be actually a very big deal, and then because of the temperature and humidity. But we will be happy to answer any questions, and Shiva has like the papers under review for this ones, and probably Professor Hasanzadeh, if there is any time later on, she is also can present about the results about it seems that there were a lot of interest about heat stress and the peer effect, and she can further elaborate on those ones.
Yes, absolutely. We'll find time for that for sure. Yes, Majid, go ahead.
Yeah, I was looking forward to hear about her outputs. Thank you.
Of course.
Well, we have maybe a minute or two if somebody has a pressing question. Well, not hearing one, I had a couple of questions. So let me ask my question. Maybe somebody else has a question in the meantime. So Shiva, again, very, very good presentation, very interesting. I have several questions, but I'll just, because of time, maybe start with one. You were talking about the frontal cortex and the motor cortex and the various impacts that you were trying to monitor. I was wondering that if you were able to identify which stressors impact the frontal cortex versus the motor cortex.
Which stressors?
Yeah.
Okay. Thank you so much for this question. So it's kind of So if we have a stressor, for example, in the presentation that I explained that I have task stressors, time pressure and mental demand. So I was investigating the effect of those stressors on each cortex separately, because they have different functionalities. So on prefrontal cortex, I know the functionality of the prefrontal cortex. So as I explained, it is important for decision making, working memory, and risk perception. So when I see the increases in brain activation in that area, it is showing me their mental resources for decision making were engaged under these stressors. And we could see that the demand, for example, on their mental resources during the last condition, that was the most stressful condition, was higher. But when I'm looking at the motor cortex, I'm looking at that from a different point of view. I know that motor cortex is important for motor planning and executing of movements. For example, if I had the experiment that subjects didn't need to move, they were just sitting somewhere and then they were engaging with some stressful things. So that in that time, motor cortex was not important for me. But because we also had movements during the task, so I could see increases within the motor cortex. So I was correlating these ones with the thing that I mentioned, that they were using the actual hockey stick with the same weight, they were moving that, and we could see that as the situation got more complicated and more hard because of the time pressure, so we could see more increases in motor cortex. So generally, if I want to answer to your question shortly, is that we need to investigate the effect of stressors on these two cortexes based on the functionality of those cortexes.
Okay. And I was wondering if, you were able to isolate that for different heat levels also. Did you see any variation if high temperatures were high? Did that impact one or the other more?
You mean the brain activation or generally?
The brain activation, particularly with respect to the frontal or the motor.
Okay,
cortex.
so that was a very great question that is related to the second part that I didn't explain. So in the roofing task, workers needed, because for the second one, I asked subjects to perform the roofing task under heat. So the task was the roofing task. So they needed to be on the roof. They needed to go up and down and install the shingles with the actual hammer. So they needed to be active a lot to perform. There were lots of physical activity in that experiment. And that was the reason that I didn't use the FNIRs in that experiment during the task, because there were lots of motion artifacts and the data was not reliable for me. But what I did is I measured the brain activation after the task when I asked them to perform a hazard identification task on a screen, because I wanted to see how much that heat stress had affected their mental fatigue after the task, that they were also physically fatigued. So I measured their brain activation there because they were sitting on and they were just watching some pictures on the screen, and I asked them to identify the hazards after being exposed to different levels of heat stress. So I could see the brain activation there, that, for example, when they were tired, they were exhausted because of the physical fatigue and also the heat stress that they were exposed to, I could see that the brain activation is kind of decreasing compared to the time that they were doing the task in a normal condition and they were more fresh and not that much exhausted.
Okay, great. Yeah, thank you.
So I have something to add to what Shiva mentioned. So Shiva has also a paper under review that is about how to classify and predict who is gonna experience these the task stressors based on their brain activation. So coming back to your first question, is that there are some representative area, not a specific area, there are some representative areas of the brains that collecting data in real time from them and then continuously can could help her in order to identify who is more at risk of experiencing these task stressors as well. But one of the things about the brain is that the brain areas are communicating with each other very, very fast. So which means that when something is happening, all the brain are engaged with the task. But which one is more? It's actually related to more about the task that they are doing, as Shiva mentioned. But she was able to identify the main channels or cortex in the brain that they are related to those task stressors, that by monitoring them, she was able to successfully predict who is actually were under highest time pressure or were exposed to the highest temperature or experience like a heat stress or how the thermal stressors impacted their brain. But as I said, like it's always that go from the vision to auditory to prefrontal to the motor. So just there are like the information or like the activation is just like connected that much, because the FNER is also looking at the like the oxygen level in the brain. So that's why that like she didn't include that one in the presentation, but we call it connectivity. So connectivity between different cortices in the like the brain, because one of them will activate and how it will impact the other one because of the decision that they will make. But yes, she was able to identify which channels and which cortices actually can help her to do the prediction and identify who is more at risk of experiencing these stressors.
Okay, great. Yeah, thank you. So with that note, we have already passed our allocated time, but this was so interesting that you know, we had a number of questions. I still have a few questions, but maybe we can discuss that later.
Yeah.
So with that said, thank you again, both of you, for that very interesting presentation. And you know, let's open our mics and give them a big round of applause if you don't mind, all of you. Thank you very much.
Thank you. Thank you so much. Thank you so much, Professor Hasanzadeh.
So
Thank you for the
look forward.
opportunity. Great job, Shiva.
Thank you.
Yes, great job. And those who are in the audience, you know, look forward to the upcoming seminars. There will be one every Friday. And as I said, we will be presenting women researchers in the built environment. So see you again next time. Thanks.
Thank you.
Bye.
Bye, everybody. Bye.
Bye.